we're going to be finishing up, like I said, writing exponential models. And then we're going to start in and get solidly into Unit 8. Unit 8 is short, but there's basically like 2 tricks you need to know. One trick and one skill you need to know. And if you pick up those 2 things, everything else kind of goes pretty smoothly. Okay. Today, you have do math direct and inverse variation. And remember, all that is just reading the words, figuring out whether it says direct or inverse in there, directly or inversely in there. So then you grab the right formula, either y equals kx or y equals k over x, and then take the point, the xy, the one point that you're given. Remember, so as you go along your things, every point will have a specific xy. So just at one point, we've given you 1 point and what the xy is at that point. You can plug those in to figure out what k is, so then you'll have the formula for all of them. Right? Once you know what k is, y equals 320, whatever, if k is 320, 320x, or y equals 320 over x, depending what's indirect or inverse, direct or inverse. So all you gotta do is you find your k, and then write your formula. And then you can use that to solve any other problems you want. You have for that. Wednesday is exponential functions, which we went over last class. How to figure out whether things, how to graph things, right? Given 2 points on the exponential function, how to graph them. Right? You're given 1 point, you're always given the initial amount, which is the y-intercept. So you find the y-intercept, that's your initial amount. That number, that's your c, whatever the y is when x is 0. And then you're given one other point, which you plug in to figure out that you can use to find a, to kind of sort out what a is. And then Friday, this might be a little early. I might need to move this. I'm going to try to get it. Yeah, your exam's on Monday, so we'll try to, we'll leave that as it is, because you need to try to get those homeworks done before your exam, because those will help you on the exam. The exam is next Monday. Like I said, come at 10:30 if you want some extra time. I'll let you start at 10:30. And then we're going to review units 1 through 3 after the exam.
How much more credit is the exam compared to like homework assignments?
Homework assignments are worth 30% of your grade, so they're worth quite a bit. What was your other question?
How much are the exams?
Oh, the exams are
like
worth.
The final.
How much are the exams worth? The exams are worth 8%. Is it?
That's it?
27.
Exams.
27. 9% each.
27.
Yeah. So 9% each, and the file's worth 18%. So the final exam and the exam 3 are worth the same amount as all of your homeworks put together.
Okay. And
Those
is
2
the
exams.
final exam like a bit more than?
Yeah, double.
Oh, okay.
Yeah.
Yeah, double.
And remember that the final exam also has that bonus of if you did poorly on one exam, or you didn't do what you'd like to have gotten on one exam, I'll take your final exam and I'll average it with that exam and I'll rate to raise up that exam. So say you got a 40 on, so you got, say exam 3, well, hopefully not, you got a 40% on exam 3, and then on the final, you got a 70%, then I will change this to 40 plus 70. Well, let's make it easier. We'll make it 80, because that's an easier number to round for everybody. So I'll change this to 60%, because 40 averaged with 80 is 60. And then obviously I'll leave that at 80%.
But if it's like one you got 74 and the other one you got like 82, then would that be enough to?
Yeah. If your file is higher than any of your exam grades, I'll bump them up, whatever, a little bit, whatever the difference is between them.
And
Yeah.
you won't do that if it's like lower?
Yeah, if it's lower, I'm not going to do that.
Okay.
Yeah, David?
On exam 3, what if you get higher than 40?
Well, whatever you get, it doesn't matter. If you get higher on your final, I will average exam 3 and your whatever your lowest exam score is and your final. Whatever the lowest exam score.
And
It could be exam 3, it could be exam 2, it could be exam 1. If one exam score, if you got low on one exam score and you get higher on your final, I will average those two and raise that lowest exam score.
And, will we, for like the first 2 exams, you let us use like the flashcards. Would
Yeah.
that be allowed for final?
Yes.
For the final?
You still get just one though.
Yeah.
This one,
Yeah. Kelly?
Oh, no, that kind of answers the question. I was just gonna ask if the equations are gonna be on this exam, or if we're gonna
I will have some equations on the exam also, but also you have one index card, one-sided. Yeah.
So we had to put all
So-
the exams in school.
Right, so the quotes, the stuff that I will give you is, I believe I give you, those 5. I'll put inverse variation, y equals k over x. Direct variation, y equals kx. Quadratic formula, I'll write out what the quadratic formula is. I think I might write vertex, negative b over 2a. So I'll give you that. I'll give you like those 4 things. Everything else is kind of on you though. Is that sort of
And it's a 4x6 index card.
4x6 index?
3x5.
3 by 5, 3 by 5, yeah. Oh, and I also give you the 2 things that we're going to see for logs. So I'll give you exponential, y equals c times a to the x. I'll give you that as well. Exponential y equals c times a to the x. And then I'll give you one for logs, which I will show you later today.
I think I'm gonna need a list of what we'll have.
Yeah.
I'm gonna remember this.
So for right now, let's just pull out let's get going so that we can actually cover the material, so that we, we'll be prepared for these exams. So we're going to go to writing exponential models. So it looks like this is the front page of it. It's that one where it's really dense, and you all had to grab some scratch paper to work with it. So hopefully you still have that scratch paper, because I think that I might be out of scratch paper. It appears that I am. So yeah. Okay. So let's go ahead and, I believe, again, remember, just a couple of comments. Here's it could be either written as y equals a times b to the x or c times a to the x. They're the same formula. It's just, it doesn't matter. It just means something, a multiplier in front, which is your initial amount, times, bless you, times a base, bless you again, raised to the x power. That's really what it's all about. So this is kind of the one that I'm sort of focusing on. And I put parentheses around here because that just seems to be a little bit clearer for folks. Where this is your initial amount. Initial means initially to start with. You can write starting amount if you want. Also known as kind of your y-intercept. And this is your base, which is also known as your growth factor. It's also sometimes called the decay factor if it makes it decrease, if it's less than 1. But either way, it's your factor. Yeah, exactly, a lowering growth factor. And then again, y and x, those are your variables. They are not a number. Right? Y and x are the variables. Those are the things that vary in the problem. C and A are fixed numbers. They're constants. In other words, once you find them, that's it. They don't change for that problem. They change from problem to problem. But the equation of this exponential, C is a number, and it stays at that number. A is a number, it stays at that number. And then your x and your y will change to make your curve. Okay, so our goal is to figure out what C and A are. We did this we finished this one, didn't we?
Yeah.
Okay, so let's move on to, oh, we talked about this, right, growth and decay factors. So our views again, right? So if I have, say my C is 5, if my A is 1, there's no growth, no change. Because I'll have Y equals my C, what's my C again?
C is 5.
5 times 1 to the X. No matter what X is, 1 to any power is always going to be 1. 1 to the 100th power is 1, 1 to the 0 power is 1, 1 to any power is just 1. So this is just Y equals 5. This would just be a line, a straight line. So everyone kind of understand what I'm saying? So that would just be, here, I think that's what's involved. Y equals 5 times 1 to the X. It's just a straight line, look at it. There it is. Because no matter what you put in for X, this part is just 1, so Y is always 5. It's just a straight line. But once I start making this not 1, 1.1, now all of a sudden it changes. Does everyone see that?
It's gonna be 1.00.
0, 0, 1. Even that changes a little bit. You just have to like zoom out to see it change. And it'll stay like that for a long time, and then, bam, it goes up. See that?
Yeah.
Or how about, or if I can make it lower than 1, like 0.999. Oops, 0.9, comma. See, and it'll do that same sort of thing.
But the other way.
Yeah, but the other way, exactly. So, because it's decreasing. So that's interesting. So if it's less than 1, that means it's decreasing a little bit each time. And it's going to be, it's going to start off really big and go really small. If it's bigger than 1, that means it's increasing. So it's going to start off really small and then go really big. Does that sort of make sense for folks? So if it's less than 1, it's decreasing. Anytime it's decreasing, it's got to start off super high and then come down. If it's larger than 1, it's increasing, which means it has to start off at 0 and then go really high up. So pretty much for all of these basic ones, it kind of either starts at 0 or it ends at 0, one or the other.
But doesn't it never touch 0?
And it will never touch 0, exactly. So it looks like it's hitting 0, but really it's just going just barely above 0 and not actually touching 0. So that's this whole increase, decrease. So you always start off with 1, 100%, right? And remember 100% would be that it is just a straight line. And if you zoomed in, you can see how it's just above, it's just at 5. And then if you add stuff to it, then it increases and goes up. You subtract stuff from it and make it, so this is, 1 is 100%. Remember, so if I have all of our class, 100% of our class, that'd be I have one whole class. Or if I eat 100% of the pizza, I eat one pizza. So decimal-wise, 1 is the same thing as 100%. So this means 100%. If I decrease, say I decrease 25%, that means instead of having 100%, I'd have how much? 75%. So my multiplier would be 75. And you'll see it starts off big and then drops. So it's always, you always start with, you always start with 100%, and if you grow, then you're going to add some percentage to your 100%. If you're going to decay, then you're going to subtract some percent from your 100%. And then we write that as a decimal. So this is our, what we call, they sometimes call this your rate, your rate of decrease or your rate of increase. Your growth factor, though, is the multiplier. So that's the 100% plus or minus that amount. Is everyone on board? So this part here that you're subtracting or adding, that's your rate that you're increasing or decreasing by. And then the factor is 100% plus that. Because a factor is what you multiply, so the multiplier. Okay, so let me go ahead and.
Okay, the factor is the bigger part.
So let me
Like the
show you this.
75 instead of
So-
the 25?
If I decay, so if I grow, if I grow 30% each year, then my factor is 130%, which as decimal would be 1.3. Because change from percent to decimal, you move the decimal place over twice, or think about just 130 cents. 130 cents, I'd write that as 1.3 or 1.30. So then I'd have y equals 5 times 1.3 to the x. Does that sort of follow for folks?
Would it also work if it was like 200%?
Yes, you can. Now, here's the thing. Decay, if I have 100% of something, I cannot lose more than 100% of it. So understand what I'm saying? So you can grow by more than 200%. Right? I can have $5 and invest it and have that $5, I can bet it on whoever to win, and that can grow 300% and become $20 if I bet on the right thing, but I can't lose more than my $5. Is everyone kind of following? So I can't lose more than 100%.
Mhm.
So the decay factor can only go down to, at the very most, 100%. And at that point, it would just go through one cycle and then it'd be nothing.
The math doesn't deal with that.
Right, exactly. Whereas here, but it can grow by more than 100%.
Yeah.
Yeah, but say I lost, so say I lose 10% each year, right? Then my factor would be 90%. So I'm going to understand 100% minus 10%. So that would be 0.9. So then I would have y equals 5 times 0.9 to the x. Should I make this purple? Like that. Right, so again, your growth factor or decay factor, that's as a decimal, not as a percent, as a decimal, that's your A. Good. So A is my growth factor, right, or my base. Okay, so we'll do a couple of these. I will actually let you folks do, try the first two by yourselves, 1 and 2. So figure out what the exponential model is. So I need the y equals, figure out what C is, your initial amount, multiplied by your factor, your growth factor, your decay factor, to the x. That's what I want. And then find and interpret f of 4 for each of these.
You might have did one already.
I think
You did.
I did, but
Oh,
do it again. Do it, for people who weren't here, help them through that one.